Hi, I'm Emily from Emily Learning. In this video here, we'll be going through the Cambridge International AS and A level paper, the May-June 2024 math paper. So let's take a look at question 1. In question 1, we are asked to express 3y squared minus 2y minus 15 in the form, complete the square form, 3 bracket y plus a squared plus b, where a and b are constants. Alright, so let's do it together. So we know that this is simply so we have 3y squared minus 12y minus 15, and we want to write it in this form here. Okay, if you can remember to complete the square method, then just simply use it. If not, what you can do is you can expand this out and then compare coefficient. So based on this, we know that minus 12y is the same as 6ay. So in other words, minus 12 is equals to 6a. So we do know that a is equals to negative 2. Similarly, we know that minus 15 doesn't have any y in it. So it is equals to 3a squared plus b. So minus 15 is equals to 3a squared plus b. And we know that a is minus 2. So from here, we can find what b is. So b is essentially minus 15 minus 12, right? Because this is 12, then you bring it over is minus 12. So therefore, b is negative 27. So rewrite this. So we know that 3y squared minus 12y minus 15 is equals to 3y minus 2 squared minus 27. So this is the answer. This is the complete the square form of this one here. Right. Next, you're asked to find the exact solutions of the equation 3x to the power of 4 minus 12x squared minus 15 equals to 0. So we see the word hence. In other words, we need to make use of part A to solve part B. Okay, so let's take a look. So what do you notice is the difference between this and this here? Okay, let's ignore the equals to 0 first. So if you look at this, 3y squared minus 12y minus 15, 3x to the power of 4 minus 12x squared minus 15. What's the difference? Well, the only difference is that they have replaced the y with x squared, right? So let's do it. So we know that 3y squared minus 12y minus 15, let's let it be equals to 0. Then we replace y with x squared. And once we replace y with x squared, we'll get 3x squared minus 12x squared minus 15 equals to 0. And if I were to simplify it, I will simply get this, right? And because they want us to use what we have from before, so in other words, I'm going to rewrite this as this form here, but switching my y into x squared. Okay, so after this, I need to solve, right? So let's do it. X squared minus 2 squared is equals to 27 over 3, okay? So x squared minus 2 squared is equals to 9. So to find x squared minus 2, I'll square root both sides. Okay, and I will end up having plus minus 3 here. So in other words, I know that x squared minus 2 equals to 3, or x squared minus 2 equals to minus 3. So x squared is equals to 5. So x is equals to plus minus of square root 5. here x squared is equals to minus 1, right? So I will have no solutions for this. Okay, reason is because since x squared should be greater than 0 for greater than or equals to 0 for all real values of x, therefore, okay, there are no solutions, no real solutions for x squared equals to minus 1. So therefore, x is equals to root 5 or minus root 5. Okay, so this is the exact solution for this equation here. Alright. Now with that, let's move on to question 2. So in question 2, you are told that the diagram shows two curves. Okay. One curve has equation 1, y equals to sine x, and the other curve has equation y equals to fx. So which one is the y equals to sine x curve? Okay, one look you should know that this is the y equals to sine x curve. And this one here is the y equals to fx curve. Reason is because we know for y equals to sine x, the maximum value of y is 1. Minimum value of y is minus 1, right? So maximum value is 1, minimum is minus 1. Okay, and this is what we have. So therefore, this is y equals to sine x. Okay, for this curve here, the maximum value is 1, but the minimum value is minus 5. So definitely not sine x, y equals to sine x. Furthermore, it is not the center or the equilibrium line is not at the x-axis for this curve here. So therefore, we know that this is not y equals to sine x. Okay, this is y equals to sine x. So now what we asked for, in order to transform the curve y equals to sine x to the curve y equals to fx, okay, the curve y equals to sine x is first reflected in the x-axis. So what happens when you reflect about the x-axis? Something that looks like this will now becomes this way, right? And this is what we notice, okay? Here is maximum. Now this is minimum, right? So because it has been reflected about the x-axis. So we know that fx is probably, so once it is reflected in the x-axis, your y equals to sine x becomes y equals to minus sine x, right? Then next, there are two further transformation. So what are the two other transformation? Okay, so let's take a look at this. Recall that whenever we have a sine or cosine graph, we always talk about amplitude. And we also talk about the period. So for y equals to sine x, the period will be 2 pi, right? So every 2 pi, you make a complete cycle. And the amplitude is 1. So the maximum is 1 and the minimum is minus 1. So now, for y equals to fx, what do we notice? Well, I noticed that, you notice that this is where the center is, right? It's like the equilibrium line. Okay, so based on this, I know that the amplitude is actually 1, 2, 3 units. So for y equals to fx, the amplitude is now 3 units, right? Okay? And I know that the period still remains as 2 pi. See, it takes 2 pi to complete one cycle. So what do I know? Well, if I have a graph y equals to sine, if I have a graph a equal a sine bx, okay, a will be the amplitude, right? And the period will be 2 pi over b, right? So because I know that the period remains the same, okay, but the amplitude is now tripled. So I know that probably this has something to do with y equals to negative 3 sine x. Okay, why negative? Because it has already been reflected in the x-axis, so your sine x becomes minus sine x. Okay, then amplitude is 3, right? So you need to have a 3 here, so multiply by 3. The period is still 2 pi, so that means here remains as x. Alright, so with that being said, right, let's take a look at the next thing. What do we need to do? Well, we need to take a look at this equation, right? We need to know, okay, so now I know that if I have y equals to negative 3 sine x, it will look something like this, right? Okay. Oops, sorry, negative. Maybe let me draw it here. So if I have negative 3 sine x, it should look something like this. Okay, and do the same again. Okay, this one is this green line here is y equals to negative 3 sine x, right? Agree? Okay, but it's not right. It shifts down by 2 units. Okay, so we know that what we need to do 2 transformations, right? First, I need to go from y equals to minus sine x to y equals to minus 3 sine x. Next, I need to shift it down by 2 units. Shift it down by 2 units, that means I minus 2 here. So what is the transformation that goes from y equals to minus sine x to y equals to minus 3 sine x? Well, we first need to stretch y equals to fx, by a scale factor of 3 units, parallel, in the y direction, so that is the first thing, right? Followed by a translation of negative 2 units in the y direction. Okay, so this is what we do. So first, we need to multiply by minus 3, which is basically a stretch, right? Or scale. So when you talk about scale, you must talk about in which direction, and then what is the scale factor. So scale factor of 3 in the y direction, because we are scaling this way. Next, we are going to move the whole graph down by 2 units, right? Moving it down or to the left or to the right by a certain number of units is known as translation. So you talk about translation by how many units in what direction. Okay, so that's the answer for part A. So next, we are asked to find fx in terms of sine x. So we have already talked about it. It's essentially y equals to minus 3 sine x minus 2. Okay, now let's move on to question 3. So in question 3, the coefficient of x cubed in the expansion of this is 160. So find the value of the constants of A. So basically, what is this question about? It is probably about binomial expansion, right? So let's do it. So I am asked for the coefficient of x cubed. So don't need to remember the formula. We can use the formula booklet for this. Here's the list of the formulas. And what we will be interested in using for this question is that for the binomial series, okay, which is here. Okay, so what do we have? We have 3 plus ax to the power of 6, right? So we have 3 plus ax to the power of 6. And we are interested in the coefficient of x cubed. Okay? So we know that we should let this is in the correct position because we want the power of x to be increasing, right? Okay, so if I want it to be power 3 for x, okay, basically this is what I want, right? So I will want this one here. So I know that the term with x cubed is essentially n. So in this case, the n is 6, right? Because the power is 6. So n is 6. 6 choose 3. Then a, which is 3 here, to the power of 6 minus 3, which is 3. Then b is ax to the power of 3. All right. So let's do it in our question paper. So term with x cubed is 6 choose 3, 3 to the power of 3 ax cubed. Okay, next use your calculator to evaluate 6 choose 3, which give us 20. Okay, then let's times 3 cubed, which is 27. Then we expand this is a cubed x cubed, right? So I know 540 a cubed x cubed is the term with x cubed. So the coefficient is 540 a cubed. So 540 a cubed is equals to 160, right? So solving for a, it will be 160 over 540, then cube rooted. Okay, so let's just type everything into the calculator. Okay, and you'll get the answer of 2/3. Okay, so the answer for 3a is 2/3. Moving on to part B, hence you're asked to find the coefficient of x cubed in this expansion. So we have 3 plus ax to the power of 6, 1 minus 2x. So in order to find the coefficient of x cubed in this expansion, we know that we are going to multiply the terms together, right? So because we are interested in x cubed, we'll ignore everything except for those that will give us x cubed. And I know that 160 x cubed times 1 will give me a term with x cubed. Now, there will be another term here in the expansion of 3 plus ax to the power of 6, okay, which will need to be multiplied with minus 2x to give us an x cubed term. And what would it be? It will be a term with x squared, right? So let me do dot dot. Okay, maybe I need more space. So let me do this. I'll have dot 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 plus. Okay, I want a term with x squared, right? So I know that based on this formula booklet that, okay, if I want a term with x squared, it'll be n or 6. 6 choose 2 and this one, right? So let me first write this term with x squared. Will be 6 choose 2, then 3 to the power of 6 minus 2, which is 4, then ax squared, right? Okay, and I know from this previous part that the a is 2/3, so I'll just change this to 2/3. Okay, so let's write it in. 6 choose 2. Okay, maybe I really need more space. Six choose 2. Okay, 3 to the power of 4, then 2/3 x squared. Okay, then I already have a plus sign here, so I don't need, but I do need to present it nicely. So let me write the dot 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 nicely first with a bracket. Okay, So basically, I know that I can just type this into the calculator, right? So I type 6 choose 2, okay, times 3 to the power of 4 times 2 over 3 square. I'll get 540. So I know that I essentially have dot 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 plus 540x squared plus 160x cubed plus dot dot dot. Okay, we only need these two terms because we are only interested in x cubed, right? So I know that 540 multiplied by 540x squared multiplied by minus 2x will give me a term with x cubed, right? Okay, so I take 540 times minus 2, I get negative 1080x cubed. Similarly, if I take 160x cubed times 1, I'll get a term with x cubed as well. Okay, so now let's do this. Minus 1080 plus 160, I get negative 920x cubed. So let's write in the coefficient. Goes to negative 920. Okay, because this is the coefficient of x cubed, it's just minus 920. Alright, with that, let's move on to question 4. So in question 4, you are told that the equation of a curve is y equals to fx, where fx is this. The following points lie on the curve. So these points are on the curve. Non-exact values have been given to 5 decimal place. So what are we asked for? We are asked for k, right? Find the value of k given, give your answers correct to 5 decimal place. So we know that this is the x value and this is the y value. And since this point line or this curve, if I sub in this value here, it should satisfy this equation, right? So I know that k is essentially equals to 2 times 2.0001 minus 1. Okay, then 2.0001 minus 2, then holding minus 2. So type it into your calculator and you will get the answer. So if you type it into a calculator, you should get 4.00063 when corrected to 5 decimal place. Right. Next, the table shows the gradient of chord AB, AC, AD, and AF. Okay, so find the gradient of AE, give your answer correct to 4 decimal place. So this is point A. And this is point E, right? To find gradient, we will take y. So let's assume that this is x1 and this one is y1. This is x2 and y2. So gradient is equals to y2 minus y1 over x2 minus x1, right? So let's do it. So we have gradient of chord AE, so it's equals to this 4.63566 minus 4 over 2.1 minus 2. Type it into the calculator and then correct to 4 decimal place. You will get 6.3566. Okay. So you're asked to deduce the value of f prime 2 using the values in the table. Okay. So if you were to look at this, okay, so let me first put it here, 6.3566. So what are we actually doing? So let's assume that, right, if we have a curve, let's just assume that it looks something like this. Okay, and I want to find the gradient at 2. Okay, so I want, this is the actual gradient, right? The gradient of this line is the actual gradient. But I can also do an approximation. So what type of approximation can I do? Well, I can take points here, right? Okay, and find what is the gradient of this chord. Okay, and I can take this point here, find what is the gradient of this chord. So the closer the other point that I use to estimate this gradient. So the closer the red point is to x equals to 2. So this is the point at x equals to 2, right? So x equals to 2, the point at x equals to 2. The closer the other point used, okay, to estimate the gradient, the more accurate the estimation is. So in other words, if you to look at point A, point B, point C, point D, and so on, point B is the closest to A. So in other words, right, I know from here that, right, if I want to estimate the gradient of this tangent at x equals to 2, the best is to use point B to estimate it because it is the closest to A compared to the other points. Okay, so if I were to choose any of the values here to estimate the value of the gradient, I would definitely use the chord AB to estimate the gradient of the tangent at x equals to 2 or at point A. Okay, and it should be close to this. Okay, then another thing to note is you notice that these values here are increasing, right? As you go further and further away from the point. So if you use this value here, okay, the gradient, so if I use a point that is further away to the right, okay, of A, so this is point A, right? This is maybe point B, this is then C, then D, then E, then F, right? You notice as you go further away from A to the right of it, okay, the gradient increases. So if you have to compare the gradient at A and the chord AB, it is slightly smaller, right? So we know that it should be quite close to 6.2501, but smaller than that. So if I were to use an estimation, I will say that f prime 2 will be around 6.25 because it is smaller than 6.2501 and it is still very close to 6.2501. Okay. Next, let's look at question 5a. In 5a, we are asked to prove this identity. All right, so let's do it. So I have sine square x minus cosine x minus 1 over 1 plus cosine x. And I need to show that it's equals to this. Okay, so I know that at the end of the day, I only want cosine. So the sine square must disappear. So how do you change sine square to cosine? So remember your identity, sine square x plus cosine square x is equals to 1. So in other words, right, sine square x can be rewritten as 1 minus cosine square x, and that is what I'm going to do here. So rewrite the sine square x as 1 minus cosine square x. So now 1 minus cosine square, yep. So next, let's simplify this. So 1 minus 1 is 0, so this is gone. I have cosine square x minus cosine x. Okay, so let me factorize it. So I have never mind, let me first write this out. And I want to cancel something, right? So that later at the end of the day, I only left with cosine x. So I don't want the denominator. So if I don't want the denominator, probably I can cancel it off since I have a fraction. So I'm going to factorize the numerator. So I can factorize out cosine negative cosine x. So I'll be left with cosine x plus 1. Okay, so next I know that these two are the same, right? Cosine x plus 1 and 1 plus cosine x. So I can cancel it away and I will be left with negative cosine x, okay, which is equals to right hand side, and I have proved what I needed to prove. Now that I'm done with this, I'm asked to make use of this to solve this one. Okay, so if I had to take a look at this, this is sine square x minus cosine x minus 1, same as the numerator here. But here, instead of having 1 plus cosine x, I have 2 plus 2 cosine x. So recall that if I were to multiply this entire thing by 2, I'll have 2 plus 2 cosine x, right? Okay, so that is what I'm going to do. So first, I'll try to write this something like this here, okay? Okay, so once I have this, I know that this entire thing here okay, what can it be rewritten as? This is essentially minus cosine x, right? So I'll write this as minus cosine x over 2. Okay, so I know that minus cosine x, or maybe cosine x, equals to 1/4 divided by negative half. Okay, which is essentially negative half, right? So next, what I need to do is I need to find basic acute angle of x. Okay, and when we find basic acute angle, we do not use the negative, we just use this. Okay, and this should give us 60 degrees. Okay, next, I know that this is negative, so ASTC. So when is cosine negative? Well, when it is in the second quadrant and the third quadrant. So therefore, x is in the second and third quadrant. So to find the angle in the second quadrant, it will be 180 degree minus basic angle. To find the angle in the third quadrant, you will take 180 degree plus the basic angle. So in other words, x is equals to 120 degrees or 240 degrees. Let's move on to question 6. We are given a function which is defined by this for x is lesser than 0. So we are only looking at this part of the curve because this is where x is lesser than 0. The diagram shows the graph of y equals to fx. So this is y equals to fx. On this diagram, sketch the graph of y equals to f inverse x. Show any relevant mirror line. So what do we know about f inverse x? Well, f inverse x is the reflection of y equals to fx about the y equals to x line, right? So this is y equals to x. So I will reflect this about this line here. I will get the f inverse x, right? Okay, so I know that here this will sort of look like something like this here. Okay. So why is it so? Recall that, let's assume that this one is y equals to a, right? So remember your x and y swap. If it has an asymptote of y equals to a, now it will have the y equals to f inverse x will have an asymptote at x equals to a, right? Okay. Next, I know that it has this asymptote at the y-axis, and the y-axis takes the equation x equals to 0, right? In other words, now it will have an asymptote at y equals to 0. So therefore, you also have an asymptote here. Okay. So therefore, this is how the y equals to f inverse x graph looks like. Because they did not put in the asymptote, you do not need to draw out the asymptote, but you need to know that there is a vertical asymptote here, okay, and also a horizontal asymptote at the x-axis for f inverse x, okay. But for the final answer, you do not need to draw this, okay, but you need to show the mirror line, which is your y equals to x. Okay, so this is the mirror line. and this is your y equals to f inverse x. Okay, so that's your answer for part A. Next, find an expression for f inverse x. Okay, so let's find an expression for f inverse x. So we let y be equals to 2x squared plus 4, and we know that x is lesser than 0. So to find f inverse x, we will make x the subject, right? So we will bring everything without x over. So I know that y minus 4 is equals to 2 over x. Okay, so do a cross multiplication. So xy minus 4x is equals to 2. X bracket y minus 4 equals to 2. X is equals to 2 over y minus 4. So therefore, f inverse x, okay, just change all the y to x. Okay, so this is f inverse x. So f inverse, oh sorry, there's a square. So let me put in the square. Okay, so let me erase this first. So x is equals to plus minus square root 2 of y minus 4, right? And because x is lesser than 0, we will take the negative portion. Okay, so now we find f inverse x. So f inverse x is basically just replace the y here with x. So this will be the expression for f inverse x. Okay. Once that we have done this, let's solve the equation fx equals to 4.5. So fx equals to 4.5, that means 2 over x squared plus 4 is equals to 4.5. So in other words, I know 2 over x squared is equals to 0.5. So 0.5 x squared is equals to 2. X squared is equals to 2 over 0.5, which is 4. Therefore, x is equals to plus minus 2. But remember, x is lesser than 0. Since x is lesser than 0, therefore x is equals to minus 2. Okay, so next, explain why the equation f inverse x equals to fx has no solution, right? Okay, so if you look at the graph here, there is no point of intersection, right, between fx and f inverse x. Okay, so therefore it has no solution. So you can say from graph in A, there is no point of intersection between y equals to f inverse x and y equals to fx. So therefore, there is no solution. Okay. Next, let's move on to question 7. So this is again another circular measure. It's a circular measure question. So we do have some circular measure formulas here, which we are likely to be using. The arc length, okay, is r theta. Area of sector is half r squared theta. So let's move back here in the diagram. Angle AOD and BC are parallel lines. So these are parallel. Okay. Arc AB is part of a circle. So AB is part of a circle with center O and radius 15 cm. So if here's 15 cm, here's also 15 cm. Okay. Angle BOA is theta radians. Arc AC, arc CD, which is here, is part of a circle with center O and radius 10 cm. So here's 10 cm, here's also 10 cm. Angle COD, it's pi over 2 radians. So you're asked to show that this angle here, theta, is 0.7297, right? Okay. So if you take a look at this, these two are parallel, right? This line is parallel to this line here. So in other words, if this is 90 degrees, this is also 90 degrees. It's called alternate angles between two parallel lines, right? Okay, so what I can first say is angle BCO is equals to angle COD, okay, which is equals to pi over 2, okay? Why? This is called alternate angles between two parallel lines. Okay, now that I know that this is a this is parallel line, and so this is 90 degree, this is 90 degree, I know that at BCO is a right angle triangle. Is a right angle triangle. When BCO is a right angle triangle, I can make use of Stochastic, right? That means tangent equals to opposite over adjacent, cosine equals to adjacent over hypotenuse, sine equals to opposite over hypotenuse. All right. So I am particularly interested to find angle CBO, because angle CBO is equals to angle BOA, which is equals to theta radian. Also because I have parallel lines here, and these are alternate angles, and alternate angles are the same. So if you have a Z here, this is parallel to this line here, then these two angles are the same, right? Angle A equals to angle B, and the reason is because of alternate angles between two parallel lines. Okay, so now once I find angle CBO, okay, I will know what is theta, right? So I know that theta, tangent theta or tangent CBO is equals to not tangent, because this is the angle that I'm interested in, and this is opposite to theta, and this is hypotenuse. So if I have opposite and hypotenuse, it is sine. So sine theta is equals to this. So theta is equals to sine inverse 10 over 15. Make sure your calculator is in radian mode. Okay, then let's type it into the calculator, and you should get 0.7297 when corrected to 4 decimal places. So we have shown what we are asked to show. Okay. Next, find the perimeter and area of the shape ABCD. ABCD. Give your answers to 3 decimal places. So you're asked for perimeter and also area. Okay, so to find perimeter, I need arc length AB, okay, which is basically r theta, right? Okay, so let's start off by perimeter. So perimeter of ABCD is equals to arc length of AB, okay, plus, let's start from here. I want to start from here. Then I want to move in a clockwise direction, followed by BC, length of BC. Next, arc length of CD, plus length of AD. Okay, then I have all. So 1, 2, 3, 4, 4 sides. 1, 2, 3, 4, 4. Okay, that's accounted for. So arc length of AB is basically r theta, right? The r is 15, and the theta I found is 0.7297. BC is, oh no, I have not found it. So BC, in order to find BC, I need to use Pythagoras theorem, right? This is a right angle triangle. Here is 15, here is 10. To get BC, let's call this B square. So sorry, BC be B square. So B square is equals to 15 square minus 10 square, right? So B is equals to square root of 15 square minus 10 square. So let's do it. Write it in. 15 square minus 10 square. Arc length of CD, okay, this is pi over 2, right? So I have pi over 2 times the radius, which is 10. Finally, AD is 15 plus 10. Okay, I'm going to put everything into the calculator and I will get a length of 62.8 cm when rounded off to 3 significant figures. Alright. Next, let's find the area. So area, let's look at 3 parts, right? The sector, area of sector AOB plus area of triangle BOC, finally plus area of quarter circle, or let me just call it sector COD. Okay, and then we know that to find area is essentially half r squared theta. So area of this is half times radius square, which is 15 square, and theta is 0.7297. Area of triangle BOC, so we know that BC is this, right? It's square root of 15 square minus 10 square. So half times square root of 15 square minus 10 square times 10. Finally, find the area of this sector. Okay, so it's again half. The radius is 10 square times this angle here, which is pi over 2. Type everything into your calculator and round it off to 3 significant figures. You should get 217 cm square. Let's look at question 8. So in question 8, we are told that the first 3 terms of an AP are this, and this, where P is a constant. Find the value of the 10th term of the progression. So we know that from the booklet here, if we are interested in the AP, we want to find the 10th term, we need to know the common difference as well as the first term. The first term is already given to us. It is 25. So what we need to do is to find the common difference of the arithmetic progression. And how do we find the common difference? Well, we know that the difference between 2 subsequent terms, consecutive terms, is always the same. So if I have to take the second term minus the first term, it will be equals to the third term minus the second term. And from there, I'll be able to find the common difference. So let's do it together. So I know that let D be common difference of AP. And I know that D is equals to 4P minus 1, okay, the second term, minus the first term. Okay, D is also equals to the third term minus the second term. Okay, now I know these two are the same, right? Because for an AP, the difference is a common. So the 4P minus 26 must be equals to 14 minus 5P. So therefore, I know that 9P is equals to 40 and P is equals to 40 over 9. So the common difference D is equals to 4 times 40 over 9 minus 26, okay, which will give me minus 8 and 2 over 9. Okay, so the 10th term, U10, is equals to, based on this formula here, it is A, the first term, plus N minus 1D, where N is 10, right? So let's do it. So we should get negative 49 as the answer to this question here. Now let's take a look at part B. So in part B, we are given a geometric progression. So we are told that the first three terms of a GP are 25, 4q minus 1, 13 minus q. Now when we have a geometric progression, what do we look at? Well, we look at the first term A, which we know is 25, and we are also interested in the common ratio, okay, which is the ratio between two consecutive terms, okay, and it is a constant, okay. And we also know that q is a positive constant. We know that q is greater than 0. Find the sum to infinity of the progression. Once you know that it's sum to infinity, we also know that mod r is lesser than 1. Okay, so we first need to find r before we can find sum to infinity, because the sum to infinity takes this formula, a over 1 minus r, right? We need to use this formula as infinity, or sum to infinity is a over 1 minus r. We already have a, we need to find what is r first. So let's first find q first, and then we find r. So we know that common ratio is basically the ratio of subsequent terms. So it's the second term over the first term, which is also equals to the third term over the second term. So let's solve for this first. So do a cross multiplication. I know that I have 4q minus 1 squared is equals to 25 times 13 minus q. Let me expand this. I have 16q squared minus 8q plus 1 is equals to 325 minus 25q. Okay, simplify. I have 16q squared plus 17q minus 324. All right. Next, I will need to factorize, right? So 81. Okay, so based on this, I have q equals to 4, or q is equals to negative 81 over 16. So I have 15 over 25. So I have r equals to 3/5. Now that I found r equals to 3/5, I can find the sum to infinity, right? Which is equals to a, and it's 25 over 1 minus 3/5. Okay, so with that, I will get a value of 125 over 2, or which is the same as 62.5. You can give your answer in any of this. Okay, so that's the answer for part B. Now let's move on to question 9. So question 9 is an application of integration question. So you are told that the diagram shows part of a curve with the equation of this. Okay, and because it's an integration question, we typically will rewrite it as power minus 1/3 instead of 1 over 5x minus 4 to the power of 1/3, because it will be easier to integrate later on. Okay, so we know that this is the curve y equals to 5x minus 4 to the power of negative 1/3. And I have lines x equals to 2.4, and this horizontal line here being at y equals to 1. The curve intersects the line y equals to 1 at the point 1, 1. So here's 1, 1. And you're asked to find the exact volume of the solid generated when the shaded region is rotated through 360 degrees about the x-axis. If you have to look at the shaded region, is basically bounded by the line y equals to 1 and this curve here. So if you want to find the volume generated, so volume generated, right, when you are looking at the volume generated when it's rotated about the x-axis, it must take the form of pi integrate y square dx, right? So we know that this volume generated is basically the volume generated when this horizontal line, okay, y equals to 1, is rotated about the x-axis, okay, through 360 degrees, minus the volume generated by this curve when it is rotated, okay, 360 degree about the x-axis. So I know that it's basically pi 1 square, which is still 1, dx from x equals to 1 to x equals to 2.4 minus pi y squared again, and this time the y is this curve here, so it's 5x minus 4 to the power of negative 1/3 square dx, again from x equals to 1 to x equals to 2.4. Okay, so now integrate 1, you get x, right? Okay, from 1 to 2.4. Okay, this one, let's not integrate it yet. We will simplify it. So 5x minus 4 to the power of minus 1/3, and you square it, is basically 5x minus 4 to the power of negative 2/3. Okay. This one will be rewritten as this. So now we can integrate this, right? Integration of 5x minus 4 to the power of minus 2/3. Recall the formula. If I have integration of ax plus b to the power of n, and n is not equals to minus 1, then it will be ax plus b to the power of n plus 1 over a times n plus 1, right? And because this one I wrote it as a indefinite integral, so you plus arbitrary constant, but for this case here it's a definite integral, so don't need arbitrary constant. So coming back to this, I have minus pi, so my ax plus b is basically my 5x minus 4. Okay, now my power is minus 2/3, or n is negative 2/3, so negative 2/3 plus 1 is basically 1/3, then over a, which is 5, and then n plus 1, which is 1/3. Okay, then we will go from 1 to 2.4. Okay. So we have 1.4 pi minus pi. I'm going to sub in x equals to 2.4 here. So 5 times 2.4 will give me 12. 12 minus 4 gives me 8. Power 1/3 is basically cube root. 8. Cube root of 8 is 2. So it's 2 and 5 over 3 minus, I sub in x equals to 1 now, so 5 times 1 is 5, minus 4 is 1, cube root of 1 is 1 over 5 and 1/3 over 5 over 3. Okay, so now let's simplify this. So I have so this is essentially 3/5 pi or 0.6 pi, right? So let's take 1.4 minus 0.6. Just use your calculator, right? So it's 0.8 pi units cube. So the answer for question 9 should be 0.8 pi units cube. Now let's take a look at question 10. So in question 10, we are told that the equation of a circle is this: x minus 3 squared plus y squared equals to 18. The line with equation y equals to mx plus c passes through the point 0, minus 9 and is a tangent to the circle. So let's take a look at the equation of the circle. Circle is x minus 3 squared plus y squared equals to 18. Then for the line, we know that it is y equals to mx plus c, and it passes through the point 0, minus 9. We also know that for a line, c refers to the y-intercept, and 0, minus 9 is a y-intercept. So therefore, we know that the line takes the equation y equals to mx minus 9. Okay. Next, we are also told that the line is a tangent to the circle. Okay, so in other words, right, if I were to sub in equation 2 into 1, get a quadratic expression in terms of x, and then find the discriminant should be equals to 0, since the line and the circle are a tangent to the line is a tangent to the circle. So I will first sub 2 into 1. So this is what I get. Okay, x squared minus 6x plus 9 plus m square x square minus 18mx plus 81 minus 18. So continue to simplify. So I know that the coefficient of x square is 1 plus m square. Coefficient of x is minus 6 minus 18m. Then coefficient of constant is 9 plus 81 minus 18, which gives me 72. Okay, so once I have this, okay, I'll say since line is tangent to circle, discriminant is equals to zeros. Okay, so I'm going to apply a discriminant to this equation here. So this is my A, this is my B, this is my C, right? Discriminant is basically B squared minus 4AC. So B squared minus 4AC is equals to 0. So let's solve for this. So I have 36 plus 6 times 18 times 2, which is 216m, plus 324 m square minus 288 minus 288 m square equals to 0. So let's simplify this. So it's 36m square plus 216m, okay, then minus 252 equals to 0. Okay, let's divide everything by 36. Okay, this is what I get when I divide all terms by 36. So I can simplify it by having m plus 7, m minus 1 equals to 0. So factorize, this is what I get. Okay, so I know that m equals to negative 7 or m equals to 1. Right? So I found the two possible values of m. Next, I need to find the coordinates of the point at which the tangent touches the circle. So let me call this equation 3. So once I sub in the values of m, I need to solve for x. That will be the x coordinate of the point at which the tangent touches the circle. Okay, so let me put that in. So sub m equals to minus 7 into 3. Okay, so I have 50x squared. Okay, negative 6 minus 18 times 30. Okay, so I have minus 120x plus 72 equals to 0. Okay, for this one, I have sub m equals to 1 into 3. So I have 2x squared, okay, minus 24x plus 72 is equals to 0. So you'll notice this one will give me two answers, this one will give me two answers, but they say that you find the coordinates of the point at which the tangent. So they say there are two possible values, and for each value of m, find the coordinates of the point at which the tangent touches the circle. Alright, so let's do it. So I have this one here, okay. Okay, I will find what is x. So let's solve for this one here first. Okay, because it's too complicated, I will simply use x equals to minus b plus minus b squared minus 4ac over 2a, okay, to solve for x. It makes it a lot easier. Okay, then for this one, I can simply factorize. So this one is x squared minus 12x plus 36 equals to 0. So to get 12, it will be 6 times 12. Oh, it's basically x minus 6 square, right? Okay, so this will give me x equals to 6. For this one here, I will have 120 square. Oh, it's basically, because this part, if you type it into a calculator, is 0. So it's basically 120 over 100, which is 1.2. So because it is a tangent, right? So at this point here, okay, the line and the curve meets. So this, its x and y value must satisfy the equation of both the circle as well as the line. So I am going to sub this value here into either equation 1 or 2 to find the value of y. So y is equals to, let me use m, x, I'll like this because it's simpler, minus 9. While for this, you have y equals to m, which is 1, x minus 9, which is negative 3 here. Negative 17.4. So we know that when x is equals to, when m is equals to negative 7, the coordinates required is 1.2 comma negative 17.4. Okay, whereas when m is 1, the required coordinates is 6 comma minus 3, and that is the answer for this question here. Let's move on to question 11. Okay, so question 11 is you are given this function and they are asking for the set of values of x for which fx is decreasing. So this is an application of differentiation question. So we know that when fx is decreasing, f prime x is lesser than 0. Okay, so what we need to do first is to find an expression for f prime x. So if fx is equals to 4 over x cubed minus 3 over x plus 2, which is equals to 4x to the power of minus 3 minus 3x to the power of minus 1 plus 2. So f prime x is equals to 4 times minus 3 x to the power of minus 4 minus 3 times minus 1 x to the power of minus 2. Okay, you differentiate 2, you get 0. So it's essentially negative 12 over x to the power of minus 4 plus 3 over x squared. Okay, and let me put them together. So if it is over x to the power of 4, I have minus 12 plus 3x squared. Okay, so for f prime x to be decreasing, I know that f prime x must be lesser than 0. So in other words, this whole thing is lesser than 0. Okay, I know that since x to the power of 4 will be greater than 0 for all values of x that are real. So because this is always positive, right? So this should be negative for the whole thing to be lesser than 0. So therefore we can say that negative 12 plus 3x squared or 3x squared minus 12 is lesser than 0. Let's divide all terms by 3. So we have x squared minus 4 is lesser than 0. So if I were to do a factorization, I will get something like this. Okay, so it based on this graph here, it is minus 2 and 2. Okay, so I know that it is lesser than 0. So I know that x is in between minus 2 to 2. But if you write this as the answer, you won't be correct because you're given that x is not equals to 0. So you need to exclude the 0. So what do? Okay, So you write this, right? So how do I combine these? So in other words, I need to eliminate the 0. So I can write it as, so x takes -2 to 0 or 0 to 2. Then in that way, I will not include the 0. Okay? So the set of values of x, okay, if I want to write it in set notation, I can write that x dot dot x is real, okay, this one, then comma x is real, or I can write it in set notation, okay, as -2 to 0, because I have a round bracket, so that means it doesn't include -2 and 0, or 0 to 2. So I can also write it as this, as set notation. Okay, let's take a look at question B. A triangle is bounded by the y-axis, the normal to the curve at the point where x equals to 1, and the tangent to the curve at the point where x equals to -1. You're asked to find the area of this triangle. So we'll need to go back to this. So what did they say? The triangle is bounded by the y-axis. Let me write it down here, y-axis. Okay, some more. Normal to the curve at x equals to 1, normal at x equals to 1, and tangent at x equals to -1. Tangent to curve at x equals to -1. So let's look at this. So we recall that from part A, we know that it's a decreasing curve from x equals to -2 to 2, okay, excluding 0. So I know that -1 is somewhere here, -1 is around here, okay? So let me draw out the normal at x equals to 1. So the normal, so this is a tangent, so the normal should be something like this. Let me draw out the tangent. Okay, so the tangent should be something like this. Okay, so this is the tangent, this is the normal, this is the the y-axis. So in other words, we are interested in this area, right? So what do we need from this area? Well, we do need to find the point of intersection between the normal and the tangent, because once we have the point of intersection, maybe it's A, comma B, I will know what is the height of this triangle. The height of this triangle will be A units. Okay. Next, I also need the equation of these two tangents, because I'm interested in the y-intercepts of these two lines. So when I know the y-intercept, I know what is the distance from here to here. I know the distance from here to here. I can find the base of this triangle, and I can apply my half times base times height. Height is basically the x-coordinate of the point of intersection between the normal and the tangent. And from there, I can find the area of the triangle. Okay, so what I need to do is to find the equation of the normal and tangent first. I need to, from there, find the point of intersection. Okay, and also once I have the equation of the normal and the tangent, I have the y-intercepts. Okay, so let's do it. So I need my fx, so I know that fx is 4 over x cubed minus 3 over x plus 2. F prime x at like what I found just now, f prime x is -12 plus 3x squared over 4. Okay, so now let's do this question together. So when x is equals to 1, I know my f1 is equals to, sub in x equals to 1 into this. So I have 4 minus 3 plus 2, which will give me 3, right? My f prime 1 will be -12 plus 3 over 4. No, this is not 4, it's x to the power 4, sorry. It's x to the power 4. Okay, So it is negative 12 plus 3 over 1, which will give me negative 9, right? So because I'm interested in the normal at x equals to 1, the gradient of normal is negative 1 over the gradient of tangent, which is gives me 1 over 9. So equation of normal at x equals to 1 will be y minus 3 equals to 1 over 9 x minus 1. So simplify, I have y equals to 1 over 9x, okay, then negative 1 over 9 plus 3, so plus 2 and 8 over 9. Okay, let me label this because I need to find equation of normal. Next, when x is negative 1, my f negative 1 is equals to 4 over negative 1 is negative 4. Okay, then this is 3 over x, right? Okay, so it is minus 3 over minus 1, so it becomes positive 3 plus 2. So it will give me a value of 1, right? My f prime negative 1 will give me minus 12 plus 3 over 1. So it will give me 9. Yes, it's 9. Okay. So I know equation of normal, of tangent, because it's tangent, at x equals to minus 1, okay, will be y minus 1 equals to 9 bracket x minus minus 1, so it's x plus 1. So I have y equals to 9x plus 10, right? Okay. Wait, oh, sorry. This should be negative 9. So it's negative 9x minus 9 plus 1 minus 9 plus 1, so it's minus 8. Okay, let me label this as equation 2. Okay, so let's equate 1 equals to 2. So 1 over 9x plus 2 and 8 over 9 is equals to negative 9x minus 8. So I know that 9 and 1 over 9x is equals to minus 8 minus 2 and 8 over 9. So I know that x will be equals to this divide by 9 and 1 over 9. So I'll just type it into the calculator. So it's basically negative 1 and 8 over 41. I'm not interested in the y value because I only need to know what is the x coordinates of the point of intersection to find height. Okay, so I can stop at here. So now that I have this value here, okay, I know that area of triangle is equals to half times, how to find base? Recall the base is basically 2 and 8 over 9 plus mod 8. Okay, because this one is I need the y-intercept of this normal, and the y-intercept of this normal is basically 2 and 8 over 9, right? No, here's 2 and 8 over 9. And then the y-intercept of this tangent is negative 8, because based on this equation, y equals to mx plus cc is the y-intercept. So this is the y-intercept, so it's minus 8. So to find the base of this triangle here is 8 units, right? Here's 2 and 8 over 9 units. So total is 8 plus 2 and 8 over 9. Okay? Okay, then the height is basically the x coordinate of the point of intersection, and we have already found it's 1 and 8 over 41. Because we are finding area, we do not need the negative. Okay, so this one is half times 10 8 over 9 times 1 and 8 over 41. So I'll just type everything into the calculator. So it is 6.5067. Wait, they say 3 significant figures. So it's 6.51 units square when rounded off to 3 significant figures.